be rolling right along into our next talk, which is, I need more monitors. Reverse Engineering, Jef Raskin by Eric Rangell. So, Eric, floor is yours.
Welcome to Reverse Engineering, Jef Raskin. I'm Eric Rangell, and this is all that most people know about Jef.
We're actually trying to avoid this project becoming another overbloated disaster. You didn't want to be involved back when we started this thing, and that was fine by me. I just wanted you to cut the checks. Be involved, just don't turn Macintosh into a measure of revenge for you. Everyone knows about your fallout with Team Lisa, so trust me when I say we're doing fine.
We all should be saying thank you, Jef, for many reasons, not just the Macintosh, for integer basic, programming manuals, and his commitment to user interface. And that flag was the first program that I was able to write after reading Jef Raskin's integer basic manual. This is the Apple II Basic Programming Manual. When I got an Apple IIe in 1983, my dad got me this manual, and it made no sense because it was integer basic, and it was written for the Apple II by Jef Raskin. Now, if you could find a copy physically written by Jef Raskin, it's probably worth a lot, because the one that I have has a whole bunch of Apple text here on that page. But Jef taught me how to program, very step by step with these instructions, and it's a very well organized manual. It was very highly rated, and as you page through it, you're seeing, oh, it used a cassette recorder and a TV, and he went step by step on what keys to press on the keyboard, showing you where they are, and about the control key, and setting your tape recorder, because you would have to load a tape called Color Demos, and you may have one of 5 error messages when it didn't load right, and eventually you'd get the program to run. And then all the debugging procedures. Now, when you had your TV, you would get a color bar like this, and you would have to adjust your color on your TV. So notice this statement. If the picture is flipping over, stop it the way you would for any TV show. Does anybody remember how to do that? Vertical hold. Okay. And he also has you run breakout before he starts teaching you programming. And he was very humorous because there are statements in here that will give you a real laugh. Like, when you are used to the sound of a good tape, you can quickly check a tape by ear to see if it's a computer tape or not. If you can tell what the tape contains by listening to it, you are a mutant and will go far in the computer world. When you started an Apple II, you would have to press the reset key if you didn't have an auto start ROM. And you get a random character, you press enter a few times, and I'm going to show you how to boot a floppy disk. Here's a System Master disk, slightly modified, and you can catalog your disk. So instead of loading from tape, I'm going to run start 13 to boot a 13-sector disk. And the 13-sector disk that I'm booting is the DOS 3.2.1 master from '79, and it was all integer basic programs. So here is the color demo program that you would run to adjust your TV. And this is on an Apple II monitor, so those colors are accurate. And this is the Brickout game, where you have to enter your name, and then standard colors, and then you get to play Brickout. Okay, this is with a real paddle, with a paddle that needs some adjustment, but now notice that line 0 has a ghost sub 20,000 to make Brickout conform to manual. So the version on this disk had this subroutine to draw the title screen that you saw, but if you delete that line, you get a nice splash screen that knocks out all these bricks and then gives you 2 beautiful pages of instructions, and it teaches you about putting English on a ball. Okay? and then you play the game. Now, there was also a pinball game with inverse instructions, and it is Breakout, but with a pinball machine in low-res graphics. So you have to hit the ball when it gets to the bottom, and it's a pinball game. Now, this is Satan mode of the Apple II, F666G. Okay, that's the mini assembler where you're able to type in machine language code using mnemonics and run it in the monitor. So I just wrote a small program there. But now, with the old monitor ROM, you were able to single step through every instruction and see what it did. So this is a self-modifying program that just modified 2 instructions, and when it goes back, you could see that it's loading a different value and storing it in a different place. And the trace function gave you this beautiful dump that's whizzing by on the screen, and it stops at a breakpoint. If you hit reset by accident, you'd have to type 3D0G to reconnect DOS. So this is what a dream Apple II setup would look like in 1979. You'd have your 2 disk drives and a Sony Trinitron color TV, which has the color, picture, and hue controls on the front for adjusting your color. The computer that was running those demos is a Frankenstein Apple II. I call it the Apple II ID8 because there's no D8 ROM, and it's using a reactive micro super encoder card with a homemade reset button. Okay, and we're going to open it up and take a look inside. So it has a paddle, but it's connected through a game socket externally with some LEDs for the annunciators. And it's a replica one sitting on top of it with a Arduino keyboard adapter for typing in programs. Okay, so going under the hood of this Apple, you can see the joystick connector and the 5 1/4 floppy connector. Now, what we have here is a firmware ROM card where it has reactive micro cells the images of the integer basic ROMs. So I have all them. The programmer's aid is ID0. The D8 socket is not used, and the E0, E8, F0, and F8 are the integer basic and the old monitor ROM. And there's a switch on this card. When it's up, you boot integer basic, and when it's down, you boot AppleSoft. And it also has a new power supply from Reactive Micro. So, who is Jef Raskin? Here's his Wikipedia page, and he's holding a model of the Canon Cat. Okay, so in his early life, he was born in New York, Bachelor of Science in Physics at Stony Brook, Computer Science at Penn State, where he got a PhD. One formative experience he had was a class trip to Brookhaven National Laboratory, and he met a programmer there who showed him the computer that they were using, and that really inspired him. It was a Merlin computer, which was related to the Maniac, which was derived from the ENIAC. So at Apple, he was a contract writer, and he had a company named Bannister and Crun, which was named after 2 characters, Henry Crun and Minnie Bannister from The Goon Show, a 1950s British radio comedy. Jef was Apple employee number 31, and he managed Apple Productions. Around 1979, he had an idea that he documented as the Macintosh project. He wanted it to be very easy to use. He had seen work at Xerox PARC, so he was familiar with graphic user interfaces, but his vision was more about personal productivity than the GUI or fonts or the mouse. After leaving Apple, he formed the company Information Appliance because he wanted to implement his vision of the Macintosh, and he was working on Swyftware. The term Swyft was coined by Doug McKenna, and SWYFT means superb with your favorite typing. Jeff's book, The Human Interface, outlines his philosophy, and it is based on cognitive science and psychology. He discusses the principles that should be applied for user interface design. I believe this book is still useful today for people designing new forms of interfaces, such as virtual reality and augmented reality. Jeff was also very interested in music, especially recorder music. He was also interested in model airplanes and radio-controlled gliders.
I guess there isn't really wind tunnel testing for radio control models.
I've done a lot of wind tunnel testing on my
Oh, okay. Small wind tunnels or just...
I've used wind tunnels at University of Illinois and at Princeton.
Okay.
This is a demonstration of a disk image that I created from the ROM image of the Swyft card so that it can be loaded into auxiliary RAM and run on an Apple IIe or a IIc. The 2GS, I've had problems with it, but this gives you a way of seeing what Jef Raskin's system looked like. Now, there's also the Swyft utilities on the disk, so you can create a Swyft disk by copying a Protos file to a blank disk. Okay, so here is the demonstration of what you do when you run the Swyft system. So it reads the RAM image files, and it loads them into main memory first, and then I'm going to flip the disk over because I've already prepared a Swyft disk, and I've already done the instructions shown at the bottom so that it'll load automatically. Okay, and now this is back to 1985, and this is a Swyft document. Okay, so the main innovation that Jef Raskin came up with is the leap system. So say you want to search for Jeff, I hold down the solid apple, which is to the right of the space bar on this old Apple IIe, and type JEF, and I'm already there. And I could leap backwards. So like say I hold the open apple and type RE, I'm at the word reincarnation. So like if you do solid apple space and then solid apple tab, it will leap again forward through all the words. And if you do solid apple return, it'll find the first carriage return, and solid apple tab is leap again. And then you could do open apple tab to leap backwards. And then if you just press the solid open apple or solid apple, you could go forward or backward one character. So I'm going to hit solid apple FOR. Okay, so it got me right down to the for loop. And then solid apple T, and then tab to get to the end of that word, and then hit both apples to highlight it, and then Control G executes that in AppleSoft. So that was a raspberry beep. Okay. And then it could also execute a program. So here, if I start here, so when you press the two solid apples, it's always from your previous leap to your current point. So first I'm going to leap to the 10 by typing solid apple 10, solid apple 1, okay, tab, okay. And then I'm going to leap to the run, solid apple RU, and then I press both apples to highlight all that text, and then Control G executes that in AppleSoft. And then I have a color bar. Now it also has communications built in. So to demonstrate that, I have an Apple IIc Plus connected with a Frankenstein cable to the serial port and a null modem, and I'm going to flip the monitor to the Apple IIc Plus. Okay, so here this image has the first paragraph that came from the Swiftware tutorial. Now on the IIc Plus, the Option key is your forward, even though it's to the left of the Open Apple. So it's reversed, but you can leap forward. So I'm going to leap to the B and below, B, E, and I'm here. And then I'm going to go back one, and that's where I'm going to insert some text from the Apple IIe. So I'm going to flip my monitor over to the Apple IIe window, and I'm going to send this text. So Control D is like your modem connection. So you're able to connect this to a modem and receive information from online services back in the day. So now I'm going to hit Control D, and you see it's sending line by line. And I'm going to flip back to the 2C, and it just put that program in over the communication port. And then, let's see, if I go backwards to here, and then I go leap back to the 10. Okay, now I've highlighted the program, and I'm going to run it on the 2C with a Control G. And it just ran that program. The other feature was that it would save your whole document with all the changes you made. So this is a test change. So Control L was used to access the disk. Okay, and it wrote just the tracks that it needed to on the disk. So you never had to format a disk. And then if I reboot, it will come back exactly at the same position where I left off. So just to show you that, I'm going to reboot the disk. This is an unenhanced 2E. Okay, and I'm going to flip the disk over, put in my data disk, and hit return. So it only needed one drive. And it reads just all the text from the disk, and it leaves you off where you left off. So then you can continue typing. Okay, another demo I want to do. Let's leap back to the word test. Leap back to TES. Okay, so say you wanted to move one of these lines. So you would highlight, like say we want to move 8 and 9. What I would do is leap back to the 8. And there was no mouse here. So you would just highlight what you want. So say it's just that one line. And then I could hit delete to cut it and then leap back to where I want. So like say I wanted after line 5, I could go forward, enter, and Control A is an insert. You can download the disk images for this project at github.com/erangel/kfest2021. In the disk images directory, you'll find Swift Card Resurrected. So here I'm going to save it to the desktop. And then the other disk is a WAS image of a Swift data disk. So you could copy that image as much as you want and modify it with your own text. It has to be a WAS image because there's no specified format for the disk. It's just raw track data. It'll also work in some hardware disk drive emulators that support WAS files. Okay, so now I'm going to run the Micromate emulator and load the Swyft card resurrected disk into drive 1. The Swyft system assumed you'd only have one drive. You only need one drive. Okay, so then run the Swyft system and put your data disk into drive 1. And then you press return and we go back to the future to 1985. Now on a Mac, your right Alt key will be your solid apple and your left Alt or Option key will be the open apple. So if you want to leap to the word apple, you would press the right Option or Alt key and type APP. The Internet Archive has a Jef Raskin archive at archive.org/details/Jef Raskin. And here you could see the Swyftware manual. So you could download this manual and learn how to use Swyftware, which you just saw. What's nice is you no longer have to install a card. You can just run it on your Apple IIe or IIc from the floppy disk. Now there was an attempt to reproduce the hardware for the Swyft card by Mike Willigel. And here's the schematic. It requires a PAL or a GAL, and the ROM code has to be burned onto an EEPROM. And it goes in slot 3 for the Apple IIe. So there's a whole collection of documentation about Jef Raskin's work. The development of Swyftware led to selling the technology to Canon, which built the Canon Cat. The Cat was only on the market 6 months, and people claim that it was supposed to be marketed to professional writers, but it competed against low-end word processors for clerical staff. And that's what it looked like, a cute little computer with 256K, one 3.5-inch disk drive, black and white text on a white background monitor, and a custom keyboard. So how will the Canon Cat change my day? Yes, Kate? Here's how the Canon Cat can make your day. It'll make coffee for you. It'll put food on your table. And it'll answer your phone. It'll do everything. How nice. So it's not hard to see why the Canon Cat is so easy. Just look at all this technology. It's easy to print and dial a modem, so send your $1,500 to Canon and we'll set you right up. The GitHub page also has a link to a Canon Cat emulator on archive.org. So you could go there and run the game to emulate a Canon Cat, so you can see the experience that you had. You'd get a white screen and a ruler, and it functions very similarly to Swyftware. You have to scroll down and read more about the keys to use for the functions of the Canon Cat. The leap keys for this emulator are the same as in Micromate, the Option or Alt keys. So if I type Alt-K, we go to KansasFest. Jef Raskin's patent for the Swyftware product is online, so it is possible to learn the technical details about the system architecture this way, as well as to look at the actual Forth code. So using this code, I was able to compare the assembler code in these Forth routines with the disassembly of the ROM image file and figure out where the pieces of the ROM were supposed to reside and how the initialize routine loads it into auxiliary memory. And then I was able to put it on a bootable floppy disk. So with patents, you have to disclose everything that you're claiming as part of the invention, so all the code for Swyftware is here. To conclude, let's watch a demo of a real Canon Cat.
It's Jeff's floating head.
It's Eric.
Or Eric's floating head.
Yeah,
I was
hi.
just listening to you talk about Jef Raskin for. It's Jef Raskin back from the dead. Thank you so much. I'm looking to see if there are some. If there anybody has any questions, start throwing them in the Zoom chat. I'm gonna scroll back through.
Actually, I have some questions for people. Does anybody know where Apple got the idea for open or closed Apple keys? Was that from Xerox? Let's see. I've been answering questions in the chat as we go.
Yeah, you totally have.
Mm-hmm.
I just want to make sure they get on the so on the YouTube, so the people who are watching, all of our YouTube listeners can also get all the information. Is that a floor of Juice GS or a wall of them?
That is a Zoom background created by photographing all the issues on the floor.
Yep.
So, like if I want a donut, yeah. Or if I want to see Australia.
There's a lot. Canon Cat emulator says this is very cool. This is awesome. Ken approves of your background.
Thank you, Ken. Yeah, he's just a fascinating guy to research, and yeah, he's done so much.
That ad made me giggle.
Yeah, I know. And at the end, those boxes, that was one of the movies I found on a website that was supposed to do a movie about Jef Raskin. I don't know if it was ever made. It was like an internet movie, but you have to go into archive.org to see whatever's left of that.
So question, why did they change from fast integer basic to slow floating point basic?
I don't know if they ever used integer in the Swyft card but I know that the Swyft card was developed on Apple IIes before they produced the hardware. So, yeah, so that was so as they were building the Cat, they needed IIes to prototype the Swiftware.
How large was the Canon Cat?
It's small. Yeah, because it's like just a compact desktop machine for an office. Yeah, there's some museums out there where you could see it.
What inspired you to research Jef?
Well, actually, it was a question from the Vintage Computer Fair East last year, because I was talking about Ted Nelson, and people wanted to know if Ted was influenced by Xerox PARC in any way. And somebody mentioned the Cat because Ted did a jot word processor. So at VCF East this year, I will have both of those systems if people want to try it out. That's in Wall, New Jersey in October.
Probably the last one. Do you think there's any way to get fourth on a Swyft card like there is on the Canon Cat?
Well, the fourth that he used, it's a trans fourth, so it's like a compiled fourth. So it just keeps the addresses to each word. And but I was able to match it up to the ROM image and figure out where the words are, and then disassemble the words to see what's going on. So you could ask that in Discord if you want to follow up further.
And last one real quick. Did any of Jeff's original Mac team stay with him after Jobs took over, or did they all go with Jobs?
I wouldn't know that, but I'm sure people here would know.
All right. So it's 3:45 or 2:45. I'm looking at I'm in the East Coast. But thank you so much. That was really awesome and really
everybody.
Yeah, super cool. Lots of stuff I think we all didn't know.